Hello again, everybody. Now we're going to work on some items from Chapter 4, Systems. In fact, we're going to go into the study plan here and look at Chapter 4, and in particular 4.2. We're going to do solving systems by substitution. So I'm going to practice some problems here. We'll just pick a sample or two. Okay, here's the system. I'm going to solve this by the substitution method. This is the first of our two algebraic methods, substitution method. So I'm just going to take this system here, x plus y equals 10 and x equals 4y. And let's see, x plus y equals 10 and x equals 4y. Yes, x equals 4y. Okay. So here's our system. Now the substitution method works well usually when one of the equations is solved for one of the variables, which is what we have in this case, x equals 4y. You can use the method on any of the systems. If there's a solution, we can use it. So most of the systems can be solved with this method if you want. But the ones that are tailor-made are the ones that are already solved for one of the variables. So consider that when you solve systems. So what I'm going to do is take one of these equations. I'll take this first one here, x equals 4y. And I'm going to, since it's already solved for x, I'm going to take the expression for x, which is 4y, and substitute it into the other equation for the x. So that this equation will become 4y plus y equals 10. I've replaced the x with its expression 4y. And then this equation, since it's one unknown, one equation and one unknown, we'll just solve it for y. So we have a 5y equals 10 by combining. Then we'll divide by the 5. And we'll have a 10 over 5 here. So y will be equal to 2. Once you have that first coordinate, then we come back and we can use this equation now. So let's consider this step 2. Here's step 1. Picking one equation, substituting, solving. Step 2 is doing the so-called back substitution, we can call it. Okay, back substitution. So I'll take this x equals 4y and replace the y with a 2. So now I have 4 times 2. That's an 8. The x. So my solution then, ordered pair form, is 8, 2. Now you can do a quick check, as you always should. Let's check our first equation. Is 8 plus 2 equal to 10? Yes, it is. Second equation. Is 8 equal to 4 times 2? And I think we're in agreement on that also. So that's how you solve a system by substitution. Some of the equations will be more complicated. You have to do more algebra. But this is the essential approach, is to take one equation, solve it for one of the variables if it isn't already solved, take that expression and substitute into the other equation. Okay, that's the key. It has to go into the other equation. Right? You must work with both equations. Okay. Let's see. Maybe we can find another one here. Okay, let's go on to the next one. Let's try to find one that's okay, here's one that's a little more complicated. Y equals 4x plus 1. So let me just clear this. Okay, that's the first equation. The second one is 2y minus 5x equals 8. Alright, so here's our system. Well, again, since one of the equations is already solved for one of the variables, this first one, and I'll just use that in the second equation. So I'll take the second equation and write 2 times 4x plus 1 minus 5x equals 8. So take one equation, pick one. This one's already solved for y, so I'm not going to fight it. And put that y value into the other equation. Now I expand all this and solve as I normally would. So I have a 3x plus 2 equals 8, which means 3x would be a 6, subtracting a 2. Dividing by 3, you'll have 6 over 3, which is a 2. So x is 2, then I'll take this to my second step and substitute in place of the x, I put the 2. So it looks like I have an 8 plus 1, which is a 9. So now my ordered pair is 2, 9. And we can do a quick check of that. Does 9 equal 4 times 2 plus 1? I think check is good. And do we have 2 times 9 minus 5 times 2? Does that equal 8? 18 minus 10. I think we can see, yes, it does equal 8. So we do have a valid solution. Okay. If you have any questions, you can always email me.